Hello. So, in the previous discussion, we have discussed about the routes to produce dipropylene glycol. We discussed the last route as a production from glycerin. Now, we are moving. What will be our next steps? This will be the question because, as we have discussed, all the routes, or let's say few routes, more than one, it is around six routes to produce dipropylene glycol. The next question that comes during a project journey, what should be the next steps? So till now, if you see in sequence, what we have done, we have used, we have discussed what is dipropylene glycol, what it uses, how the market look like, and then we had discussed what are the various routes that are possible to produce the dipropylene glycol. Now, the obvious steps, it is there to select one of these steps. So, our next step will be selection of the route to produce DPG, and based on that, we will decide our plant location. So, now let's start the selection of production routes and plant location. So, what is a good route? So, when you talk about a good route to produce some chemical is that which has a high economic potential, because when you operate a chemical plant, you target any business, not a chemical plant, you target for the profitability. So, your route should be profitable. It has a high economic potential, low environmental impact, because sustainability is the key. Sustainability is the key of new businesses and the new force that will drive the businesses in the coming time, and it has readily available raw materials. Why? Because if the raw material is easily available to you, you can subsequently reduce the transportation cost. Now, and atom efficiency is also an important factor. So what is atom efficiency? So atom efficiency is a green chemistry concept. It just describes, okay, how much atoms you are using, how much atoms of given raw material used to produce the atom of the good product. There is no atom production, it's only atom transfer. So from the raw material, how much atoms are combined to produce the atoms of to produce the product. So if there is a high atom efficiency, then there will be less generation of the waste. So atom efficiency is a new thing because if the waste generation is less, the waste handling will become easy, and it is also reduce your operation cost. Then plant location decide how the next thing that we are going to discuss is plant location that decide how we are going to function to connect ourselves with the market. Plant location should be such that any incident has a minimum impact on the resident. So these are the key things that we should keep in mind when we are deciding the production route and plant location. So let's discuss the selection of production route. Before we discuss the selection, let's understand few concepts that are required when we are discussing the route selection. So first concept is selectivity. As it suggests, it is about preferences in the product. So basically what it says, moles, the formula of selectivity, if you see, it says moles of desired product form divided by the moles of total product form. So let's say you have two raw materials, A plus B in a reaction gives to C, and also C plus B combined to give D. So you have two products C and D. It says if, let's say, in a reaction C and D are produced, so the selectivity will be moles of C produced divided by moles of C plus moles of D produced. So it says if the 1 mole of the reactant is converted, what is the preference given how many moles of the desired product will be produced. Similarly, conversion. So conversion is also one important thing. Mole, it says moles of reactant reacted divided by initial mole of reactant, or 1 minus mole of reactant left divided by initial mole of the reactant. So it says in a reaction how much moles of a reactant will convert into the product. So let's say if you have 100 moles of A, and at the end of reaction you left with the 20 moles of A, then this is a 80% conversion. Conversion is important because if you have a high conversion, then it's ensure that you are utilizing your raw material efficiently in a one go. Then its next important thing is economic potential. So it says selling price of product minus cost of raw material. So what it says, let's say you are producing A gives to B. Then in this reaction, if the selling price of B is $200 and the purchasing cost of A is $100, you have a potential. Let's say the one mole, not 1 kg of A is $100 per kg, and B is $200 per kg, and A produced B. So in this hypothetical reaction, the economic potential will be $100. It means if you efficiently convert A to B and you have minimum or let's say zero operation costs and transportation and other costs, then you will have a potential to earn $100 for per kg conversion of A. So this is just so how much potential or how much margin is left for you. Then next thing is technology level. So this thing, what it say, technology level is about the process you are gonna use, what kind of confidence you have at a technological level in that process. Technology level 1 to 3 donate that technology is available on papers. What it means, someone have do the reaction in a lab, reaction was successful, it can be done, but there is no pilot plant has been made over that, and they it has not been tested even at a pilot level. So this technology will be less reliable than the technology of level 4 to 6, which donate that these technologies are used to produce a pilot scale plant. So it says, okay, yes, this technology is come from a lab on a paper, then from paper it is implemented in the pilot plant, and that pilot plant have gives good results, so we have much reliability on that process. And then level 7 to 9 denotes them being actually used in the production. So when we say some process is at level 7, it is like it is slightly start to in production. Level 9 is the highly confident, means like the process on which the most of the companies are operating and we are relying on them. So this is the confidence level on the processes. Then the next important thing is effluent. It is mostly related to sustainability and waste management. It is a waste from the plant. So we have now discussed the 5 important terms. This you should have some idea about these before we jump to the selection of production routes. So now let's compare all the 5 routes. So what you will, I am eliminating the route 6. That's the last route. That is the production from glycerin, because it is just now explored. This is route is currently in the exploration part. So using that will not be beneficial for us, and we don't have much data to carry out our project work. So I am eliminating that route. So now we are comparing route 1, route 2, route 3, route 4, and route 5. So if you consider raw material wise, if you see route 1 has a raw material of propylene oxide and water, route 2 propylene oxide and water, route 3 propylene glycol, and route 4 propene, route 5 propene, chlorine, and sodium hydroxide. So this is the raw material. It is not some comparable thing, but it is a thing we should keep, or we should summarize it in a table so that we should know how much raw material we require. So water is readily available in any plant location or near the. So the main raw material here will be PO, propylene oxide, and PZ, and so availability of raw material in terms of production. So in terms of Indian production, I am comparing how much raw material is available. So if the production is high, the raw material will be available you to easily, because as the production goes, the cost of the product is also reduced and its availability also enhanced. So in this case, availability of raw material in terms of production, you can say it is a 4 lakh tons per year for the PO. Same for the route 2. For route 3, PG is also close to 4 lakh tons per year, but the propane production is 80 lakhs tons per year, and similarly propene, Cl2 and NaOH. So here you see Cl2 NaOH production is much higher side. So I have taken the production that is a limiting. So out of the three raw material, propene production is less. So I have assumed that as the availability factor. So I have taken it 80 lakh tons per year. So this table says route 4 and route 5 have an advantage over the availability of raw material. But we can't say because it is how much raw material we require. It depends on our plant capacity, and that is decided by some other factor that we will discuss later during our project. So now let's go to the. So from this we just conclude okay, route 4 and route 5 has a, we can see, have some upper hand over the availability of raw material over the route 1, route 2 and route 3. Now if we think about the selectivity as we discussed, if 1 mole of the raw material converted, how much moles of the product will be formed? We can see selectivity for the route 1 is the highest, equal to the route 5. Route 2 has the second highest, route 4 has the third highest, and route 3 has the lowest selectivity. So from here we can see in terms of selectivity, route 1 and route 5 will be preferred, then route 2, then route 4 and then route 3. So if we talk about conversion, so route 1 has a conversion of 67%. Similarly, route 5 has a conversion of 67%. But the highest conversion that is achieved for the route 2, where we use the solid weight catalyst, and it is 99.9, which is close to 100%. And route 3 has a lowest conversion, that is 10%. Route 4 has a good conversion, that is 80. So if we arrange them in a order of conversion preference, it is route 2, route 4, route 5 and route 1, then route 3. So here now we have discussed the selectivity and other terms. Now let's move to discuss the other thing, that is the economic potential. From economic potential point of view, as we discussed, we are discussing on per ton of the product. So if you produce 1 kg of DPG, how much economic potential you have, that is for production of 1 kg of DPG, what will be the cost of the raw material and the cost of the, so here the cost, selling cost of the product is constant. So the factor that is deciding the economic potential is the cost of the raw material. So from here you see for 1 ton of product, for the route 1 we have around Rs 16,634 as economic potential. Similarly for route 2, 16,634, and the route 4 has the highest economic potential, that is 25,000, but route 5 has the lowest, that is 4,951. So this just say how much economic, how much margin that is left before adding any other cost. It is just merely the cost of raw material. It is just the cost of product minus cost of raw material. It just not use any expenses. So it is the maximum profit that you can make over selling the 1 ton of the product. Now, if you comparison the technology level, you can see on technology level also, these two are highly used methods. So these are 9 because these are proved in the industry. And route 2, route 3 and route 4 are on a paper. So technological level, they are on a low side. And if you let in each of these methods, we have a contaminated water. So we are not go much deep dive, because once the water is contaminated, there is a standard process to make it to of the waste handling to give the to purify the water. That process is similar, so we just don't deep dive because the effluent is same and the application where it used. So these are 2 and 3 in theory. Route 4 has some US patent. Route 5 is used by the spectrum technology, and route 1 is used by the solventis for the production of DPC. Now this is the one tabular form in which we have discussed the different routes and compare to select which route we should use to produce the DPC. Now we will go much deep dive. We will use the process of elimination, because till now we have just do some tabular comparison. We have tabulated the data for to have the process where we can eliminate some routes before going to the so before we decide the final route. Why the process of elimination is required? Because we have 5 routes. What is our target? To go to the at least to eliminate 2-3 routes. So we have left with 2 or 3 routes, so that we can compare them later to figure out which one will be the best. So first we are eliminating the root 2. Why? Even though high conversion is achieved and the load on the separator is reduced, an expensive catalyst is needed to get good conversion. It will increase our operating cost. The selectivity for dipropylene glycol is low. It is 41.3. It is comparatively low. And see, one thing you should always remember about selectivity versus conversion. So, if the selectivity is not high for the desired product, so what will happen? Even if, because if selectivity is not high, so for each run through a reactor, what you will get lot of the byproduct which you can't convert back to the desired product. This is the case. But in case of low conversion, what you can do? You can pass the raw material after separation continuously to make it 100% use of the raw material by passing it to multiple times through the reactor. But if selectivity is low, you are converting your raw material into the byproducts more than the product than the process which have a high selectivity, which will increase your cost. Uh, so at a glance, the economic potential is high. This method is currently only on paper and not used commercially anywhere in the world. So we are rejecting this method. Now, second, we are eliminating the route 3, liquid phase dehydration of propylene glycol, because the selectivity of dipropylene glycol from propylene glycol is very low, around 30%. Overall conversion rate for propylene glycol are also extremely low, 10%. Conversion is also low. So when conversion is low, what will happen? You are going to pass lot of raw material again and again, which will increase the size of reactor. Suppose two reactors. One reactor which have only two streams, inlet of raw material and outlet of products. But imagine a reactor which have another stream of recycled product. In that case, what will happen? Your size of reactor for same amount of production will increase, and so your manufacturing and fixed cost will increases. So that is why having low conversion is also wrong, not profitable. And the economic potential per ton of dipropylene glycol production is also very low compared to other routes. And till date, this route also has only theory on paper application, so we are rejecting this. Now, third is eliminating route 4, synthesis from propene. Very close candidate for route selection because of the economic potential and sustainability. Even though it has comparatively high conversion rate, the selectivity for dipropylene glycol through propene is just 35.5. It is the second lowest one. So, and the route has very low technological level, only 1.67. So, if technological confidence is not there, you should not select that route. So, we are uh, we are rejecting this route also. So now we have eliminated the three routes: route 3, route 4, and route 2. So we are just left with the route 1 and 5. In the next video of the selection, we will discuss about route 1 and 5 and select one of them. Till now, hope you have understand.